When you want to really master a new skill, you usually look for the official manual.
Oh, absolutely. Yeah, you want the textbook, you want the rules. Yeah.
Exactly. Because we think that if we just locate this like absolute peer-reviewed, universally accepted set of instructions, we'll achieve perfection.
We really do lean heavily on that desire for certainty.
We do. We
Yeah.
treat it like baking.
Yeah.
Like if you just follow the recipe to the exact gram, the cake will emerge flawless.
Right, because an authorized guide feels safe. It implies that that all the variables can be entirely controlled.
But then you stumble into a field like gardening,
Mm.
or really any highly localized hands-on practice, and suddenly that official manual just completely loses its structural integrity.
Oh, the theory falls apart the second it hits the soil.
Exactly. The real applicable wisdom isn't neatly printed in some textbook. It's usually buried deep inside someone's messy, highly specific personal journal.
Which is, it's the ultimate expression of experiential knowledge. The textbooks provide a theoretical baseline, sure, but personal notes. They deliver the actual survival tactics you need for a very specific set of uncontrollable environmental factors.
And that is exactly why we are bypassing the textbooks entirely for today's deep dive.
I love when we do this.
Me too. We are unpacking a very specific, incredibly dense slice of experiential knowledge from a gardener named Ang.
Okay.
Specifically, we're examining a journal entry titled Notes on Gardening Part 875, which was published on April 24th, 2026.
Part 875. Just that alone tells us we are dealing with an observer who has compiled a massive empirical data set.
Over a significant period of time, yeah.
Sifting through someone's daily routine documentation, it requires a bit of an archaeological mindset.
Oh, totally. You have to brush away the mundane details.
Right. But when you do, you often uncover these highly localized yet universally applicable insights. Ang has already executed all the trial and error for us.
So we get to just sit back and evaluate the findings. And I want to set the stage for you, the listener, because this entire deep dive is anchored purely on this one set of notes, where Ang attempts to cultivate a visually striking, notoriously difficult plant known as the butterfly plant, or Christia obcordata.
Right. The Christia obcordata, it's notoriously tricky.
Extremely. And Ang spent an immense amount of time observing this plant to arrive at this singular moment of clarity about its survival. But before we get into the biological rules of care, the source text establishes this really fascinating motivation for why this plant is even in the garden to begin with.
Yeah, the underlying catalyst for the whole documentation itself. It's pretty funny.
It really is. So Ang paints this rather stunning visual picture of it. The foliage of the Christia obcordata is described as resembling a fleet of butterflies in flight.
Which sounds incredibly aesthetic.
Right. The leaves are delicate, they're winged, they hover over the soil on these really thin stems. But the twist in the journal entry is Ang's admission. Ang writes, "I'm not particularly fond of the butterfly plant."
Which is such a pragmatic admission. I love it.
They don't even like it.
The gardener isn't blinded by affection for the subject they were studying.
No, not at all. They're only cultivating it because their significant other, their SO, was absolutely captivated by this unique, fluttering visual.
Right.
And that dynamic, the reluctant gardener and the captivated partner, that's what elevates this from just a casual hobby into a rigorous evaluation.
Because Ang doesn't just place the plant on a windowsill to appease the SO and hope for the best.
No, that would be too easy.
Right. This disagreement in aesthetic taste actually sparks a very deliberate, methodical approach. It essentially removes the emotional attachment and replaces it with scientific curiosity.
Okay, let's unpack this, because Ang takes a remarkably disciplined route here. Instead of just begrudgingly keeping one plant that they don't like, Ang actually acquires two.
Doubling down.
Yeah, and rather than keeping them together, Ang places them in completely separate, distinct areas of the property. Ang specifically refers to these areas as different microclimates. Right. This is basically a scientific relationship compromise.
Scientific relationship compromise that captures the tone perfectly. And, prioritizing the concept of a microclimate is a highly sophisticated approach to horticulture.
How so?
Well, Ang recognizes that weather is not a monolith. A garden is not a single uniform environment.
Right.
It is a series of localized habitats. A corner shielded by a wall might have fundamentally different airflow, light refraction, and temperature stability than a spot just 20 feet away.
So Ang isn't testing the plant against the broad concept of the region's overall climate.
No, not at all. They are testing it against the harsh reality of highly specific coordinates in their own backyard.
Searching for the biological baseline required to keep these really delicate leaves from perishing.
Exactly.
And that rigorous microclimate isolation brings us to the core discovery of the journal. Like, what did testing these two distinct areas actually reveal about the plant's needs?
Well, it revealed that the myriad of complex, often contradictory advice surrounding delicate houseplants can actually be distilled into a singular, non-negotiable biological mandate.
It's just such a relief,
Yeah.
honestly. And the entry promises this immediately in the title. It says, the only rule you need for a thriving butterfly plant.
And that rule is intense.
It is so intense you must keep the humidity incredibly high and the soil constantly perpetually moist.
High humidity and constant moisture. Eng establishes this as the absolute baseline for survival for the Christia obcordata.
And the evidence Eng provides to support this claim is what makes the journal entry so compelling for me. Because the rule wasn't proven by careful, measured watering with a little watering can.
No, it was proven by a recent monsoon season.
Yes. We are talking about severe, near-daily downpours, unrelenting precipitation.
Just massive amounts of water.
Massive. And instead of the plant drowning into the deluge, Eng observes that it produced lush, dense foliage.
What's fascinating here is how natural extreme weather events act as the ultimate unfiltered stress test.
Right, because you can't control it.
Exactly. A monsoon removes human intervention entirely. Eng couldn't artificially modulate the moisture levels. The atmosphere simply dictated the conditions. By observing the plant's response to an uncontrolled extreme, Eng identified the organism's true preference, rather than what some textbook assumes a houseplant requires.
But wait, let me push back on the biology of this for a second.
Yeah.
Because if we look at the mechanics of standard plant care, near-daily downpours are usually an absolute death sentence for the vast majority of terrestrial plants.
Oh, completely.
We are constantly warned about the dangers of overwatering. Doesn't keeping soil perpetually soaked lead directly to root rot? I mean, the standard advice is always to let the soil dry out so the roots don't suffocate.
You are hitting on the exact reason why Eng's observation is so critical. So, to understand why root rot happens, we have to look at cellular respiration.
Okay.
Roots do not photosynthesize, right? They are underground. So to generate energy, they actually need to consume oxygen, just like we do.
Oh, interesting.
Yeah. In healthy, well-draining soil, there are these microscopic pockets of air between the dirt particles, and the roots pull oxygen from those pockets.
Oh, I see. So when you overwater, the water floods all those tiny air pockets.
Precisely. The water displaces the oxygen. So if the soil stays saturated, the roots literally suffocate. They can no longer perform cellular respiration, the tissue dies, and then opportunistic bacteria and fungi move in to consume the rotting material.
And that is root rot.
That is root rot. So the standard mandate to let the soil dry out is actually just a strategy to replenish the oxygen in the root zone.
Which means Eng's butterfly plant surviving, or not just surviving, but thriving during a monsoon, feels like an absolute botanical anomaly.
It really does.
It is aggressively defying the mechanics of standard cellular respiration for typical houseplants. Like, it thrives in an environment that would liquefy the root system of a standard monstera or philodendron.
It demonstrates that the Christia obcordata possesses a completely different biological baseline. It's likely adapted from a highly specific evolutionary environment.
Like a swamp or something.
Yeah, maybe a floodplain or a consistently damp tropical understory. Without Eng documenting this specific reaction to the monsoon in that specific microclimate, any normal gardener would likely follow standard procedure.
Right, they let the soil dry out to protect the roots.
And inadvertently desiccate the plant.
Wow. So the golden rule is absolute saturation. But establishing that rule creates an immediate logistical nightmare, if you think about it.
Because a monsoon is temporary.
Exactly. It's a temporary seasonal event. And more importantly, remember, Eng has that second plant positioned in a completely different microclimate.
Right, the control subject, sort of.
Yeah. So if this plant requires near-aquatic saturation, placing it outside of a monsoon zone introduces an immediate environmental conflict.
The first plant succeeded because the macro environment, the monsoon, provided the necessary conditions naturally.
Naturally, yeah.
But Eng deliberately designed a second microclimate to test the limits of the plant's adaptability.
Right. And Eng notes that these plants, given their thin, delicate leaves, naturally prefer bright, indirect light. Dappled shade makes sense.
Sure.
but Ang placed the second plant in direct, scorching tropical sun.
Now, bright indirect light is a gentle environment. It minimizes the rate of transpiration, which is the process by which a plant loses water through its leaves.
Okay.
Scorching tropical sun, on the other hand, creates an aggressive vapor pressure deficit. It rapidly pulls moisture out of the foliage and just bakes the soil.
And by all laws of physics and botany, a paper-thin leaf shaped like a butterfly, sitting in direct tropical sun, should turn into absolute crisps within a few hours.
Oh, easily. The evaporation rate alone should destroy it.
But Ang documents something highly counterintuitive here. In this totally hostile lighting condition, the plant isn't just surviving, it's actually thriving.
And it is thriving because Ang recognized that the hostile lighting condition could be mitigated, but only if the biological mandate, the high humidity and constant moisture, was artificially enforced. Ang manipulated the immediate environment to counteract that aggressive evaporation.
Okay, here's where it gets really interesting. Because Ang doesn't use complex greenhouse equipment to do this.
No humidifiers or misting systems.
Right. The secret weapons are incredibly accessible. Ang uses LECA balls, which is lightweight expanded clay aggregate.
Right, those little brown clay pebbles.
Exactly, just scattered thickly across the surface of the soil. Or, alternatively, Ang notes that simply keeping a standard plant saucer permanently filled with water achieves a similar effect.
It is an elegant manipulation of the boundary layer.
The boundary layer.
Yeah, so the scorching tropical sun is attempting to execute rapid evaporation. But LECA balls are highly porous. They absorb water and release it very slowly.
Okay.
By covering the soil with these clay aggregates, Ang is creating a physical barrier that interrupts the evaporation process.
Oh, I see what you mean by the boundary layer, like a hydration force field.
A hydration force field, yes.
Because the ambient weather might be a dry, scorching heat wave, but the LECA balls are slowly off-gassing moisture, creating this microscopic, localized pocket of high humidity right at the base of the plant.
Exactly.
The sun is beating down, but the lower stems in the soil are wrapped in this dense moisture armor.
And if we connect this to the bigger picture, Ang is demonstrating a profound level of environmental hacking here.
Yeah.
Ang cannot turn off the sun, obviously, or change the geographical latitude, but Ang can alter how the plant physically experiences that sun.
Right.
By fulfilling the plant's strict moisture requirement at the root and soil level, the plant suddenly possesses the internal cellular pressure and resilience necessary to tolerate an otherwise lethal canopy environment.
That is wild. It essentially allows the plant to break the rules of its own lighting preferences.
Exactly.
And it's fascinating that Ang started this process annoyed by the Deso's aesthetic preference and is now, like, engineering invisible humidity shields using expanded clay.
A complete shift from reluctant maintenance to active environmental engineering.
Absolutely. But the success of this boundary layer manipulation and the monsoon test, it actually created an entirely new practical problem for Ang.
As success often does.
Right. Because the golden rule works perfectly. The plants in both microclimates have achieved lush, dense foliage. But when a plant thrives to that degree, well, it outgrows its space.
Hypergrowth necessitates management.
Yes. So Ang addresses the next frontier in the journal entry, which is propagation.
Right.
Up to this point, the entire data set has been focused on survival and environmental observation. But Ang notes that expanding this fleet of butterflies is technically possible through either seeds or cuttings.
However, the journal entry includes a parenthetical observation that completely eliminates one of those options.
Yeah, Ang casually drops a massive biological clue. They write, quote, "I've yet to see ours bloom."
Which represents a significant gap in the dataset.
A huge gap.
Despite Ang mastering the foliage production, despite engineering humidity shields to defeat scorching sun, the precise biological trigger required for the plant to flower remains entirely unsatisfied.
And in botany, no bloom means no pollination.
Which means no seeds.
Right. So for you listening, what does this all mean for the trajectory of the garden? Like, if the plant refuses to bloom, is Ang just stuck with the two original plants? Are they at a dead end for expanding the collection?
Well, sexual reproduction via seeds is at a dead end, yes. But vegetative propagation, cloning the plant via cuttings, that remains a viable pathway, provided you have enough healthy tissue to harvest.
And this is where Ang's pragmatism really shines through again. Ang doesn't express frustration over the lack of blooms or the missing seeds.
No.
Instead, Ang looks at the direct result of their own environmental hacking. Because the monsoon provided optimal moisture and the LECA balls provided optimal defense, The plants have grown incredibly dense.
They're huge.
They are so overgrown that they actively require a haircut.
The environmental success forced a mechanical intervention.
Exactly. So Ang writes that since the plants need to be trimmed anyway just to manage their size, it is the perfect time to try growing some new ones from cuttings. It is propagation driven by sheer necessity and efficiency.
And this raises an important question about how we approach systems, biological or otherwise.
How so?
While Ang isn't harvesting cuttings purely for the sake of a new experiment, which would risk damaging a perfectly good plant, instead, Ang integrates the propagation directly into the required maintenance cycle.
Oh, that's so smart.
The excess biomass generated by the golden rule isn't discarded. It becomes the raw material needed to bypass the lack of seeds.
Even for a plant, Ang explicitly stated they did not like. I mean, the SO's aesthetic preference initiated the experiment, but Ang's rigorous application of the scientific method resulted in mass production.
The methodology was so effective, it naturally led to scale.
So true. Let's pull the threads of this journal entry together.
Yeah.
We initiated this deep dive, searching for the value of experiential knowledge over, standard textbook theory.
Yeah.
And by examining Ang's rigorous testing of the Christia obcordata, we uncovered that this delicate plant defies the standard rules of root respiration. It absolutely demands monsoon-level moisture to survive.
And we also analyzed the physics of environmental manipulation. We saw how introducing porous materials like LA can alter the localized humidity boundary.
The moisture armor.
Yes, providing a plant with the resilience to withstand hostile conditions like direct scorching sun.
We watched a reluctant gardener isolate variables across different microclimates, basically proving that sometimes the solution to a complex problem isn't finding a new rule, but aggressively enforcing a single foundational mandate.
The golden rule of constant moisture.
Right. And Ang's framework extends far beyond the parameters of a garden.
Oh, completely. It is a highly effective model for evaluating any system. It reminds us that broadly accepted generalizations often fail in highly specific local conditions.
Yeah.
To succeed, you have to observe your own microclimates. The specific dynamics of your workspace, your daily routines, or your physical environment. You must identify the non-negotiable golden rule for that specific setting, and then utilize accessible tools to enforce it.
Find the variables you can control to protect the things that matter to you, or at least the things that matter to the people you care about.
Exactly.
But before we conclude our analysis of Ang's data, there is one final, unresolved variable in the text that I really think is worth pondering.
The missing biological trigger.
Yes. Ang documented that they have never seen the Christia obcordata bloom.
Oh.
We now understand the extreme conditions required just to maintain its foliage, right?
Right.
We know it requires the saturation of a monsoon, and we know it can utilize humidity armor to survive solar radiation. But what precise undiscovered environmental shift is necessary to trigger the flowers?
It remains an unknown data point. The current microclimates are sufficient for growth, but entirely insufficient for reproduction.
And if you just think about the complexity of that, if the baseline for simple survival is this counterintuitive, what highly specific, unobserved microclimate holds the secret to its bloom?
Is it a sudden sharp drop in barometric pressure?
Maybe. Or a specific angle of light that only occurs in late autumn. Or perhaps a temporary drought to induce a stress response. I really invite you, listening right now, to consider what those hidden blooming conditions might look like.
It's a great question.
Because just like the official manual that couldn't teach us how to navigate the monsoon, the precise conditions required to truly flourish both in biological systems and in our own lives are often waiting to be discovered in a microclimate we haven't even thought to test yet.